Hello, hello, hello. Hi guys, am I audible? Hello guys, am I audible to you all or not? Hello guys. If someone can confirm that I'm audible, then we'll continue. Yes, I am audible. Nice. Okay, so hi everyone. Welcome to the PCD of CodeChef Starters 180. And today we'll discuss the first four problems, that is A to D of Division 2. But before we do that, I want to tell you about our all new CP31 sheet. So, in case you don't know about it, it contains 31 handpicked problems in each rating from 800 up to 1900, and they are specially selected so that each problem teaches a unique idea. Added to this, you have a leaderboard right here where you can see your rank, which is based on the number of problems that you have solved. So, you can compete with your friends like that. And also, every week, 7 to 8 solutions, video solutions, will be posted on our YouTube channel. All right, so you don't need to read the text tutorial if you want to. All right, so let's begin today's PCD. I will discuss the first four problems, and let's start with problem A, array operations. You are given an array A of n positive integers, a1, a2 up to an, where n is odd. You will perform the following operations repeatedly until only one element remains. Choose any three consecutive elements in the array, say ai plus 1, and ai plus 2, for some valid index I. Remove these three elements and replace them in the same position with a single integer equal to the max of ai plus 1, a of I plus 1, and a of I plus 2 plus 1. Your task is to determine the maximum possible value of the final remaining element if you perform the operations in optimal order. Okay, so our problem here is that we are supposed to, we are given an array, right? That is a1, a2, a3 up to an. And what we have to do is that we can do an operation where n is odd, right? N is odd, and we can do an operation where we can select an index I, and um, replace a of I plus a of I. Like let's say we select a2, so then a2, a3, a4 will be replaced with a single integer, which is the maximum of a2 plus 1, a3, and a4 plus 1, right? So you will place that here in place of these three elements. So after each operation, our length decreases by 2, right? So if it is n, then it becomes n minus 2. So eventually it will become 1, right? Because initially it is odd. So if you subtract 2 repeatedly from an odd number, you will get 1. So you want to maximize this final number, right? You want to maximize this. So what is the maximum possible value of this final number? You have to tell that. All right. So let's look at the sample test cases. So one input is this, that this is 1. So there is only single integer. So answer, okay. So there is only single integer. The answer is 6. Then we have 2, 2, 2. So you can perform the operation on only these three numbers. So you can do, like, if you perform the operation on 2, 2, 2, it will become 3, right? Max of 3 comma 2 comma 3, right? And if you perform the operation on these three numbers, then it becomes max of 2 comma 2 comma 2, which is 2. So in all of these three cases, there was only a single operation that we could perform. So these test cases are pretty useless, to be honest. Like that's why, like that is the output. The output is correct. I mean, we can verify that we have understood the problem correctly. Okay. So yeah, how to solve this thing? Okay, so like we have an array, right? And we want to maximize these elements. Now, when you are doing an operation, right? When you are, suppose you are doing an operation on AI, then I am saying that either like AI, so AI plus one and AI plus two, right? So uh, either these three numbers will be replaced by a of I plus one or a of j. Sorry, it will be a of I plus one or a of I plus one or a of I plus two plus one. So I these three numbers will be either replaced by any one of these three, right? Now, if it is replaced by this number, then of course it is not good for us, because this does not increase it. Like if the operation results in this number being chosen, then no number is increased. So there is no point in doing this operation. Like before doing the operation, if the maximum of these three elements is the middle one, then there is no point in doing this operation. We are just wasting like two numbers. Basically, essentially, what we are doing, we are deleting these two elements, right? And the middle one is not increased. And let's say if we delete, like if we do an operation on these three elements and ai plus 1 is the maximum, then that means essentially we are deleting these two elements and this element is getting incremented, right? So think of it this way, that we have an array, right? We have an array of elements and we can select any three numbers, and whatever is the maximum, it will remain, and the other two will get deleted, right? And also, whichever is the maximum, it will get incremented by 1 if it is the leftmost or the rightmost one, right? So what I mean to say is that suppose there is 252 here, there is suppose 252 here, then there is no point in doing this operation, because this 5 will not increase. So essentially you are just deleting these two, but we want to maximize the final element, right? So we'll try to add 1, right? Now tell me guys that how many times can we perform the operation? Like let's say the length of the array is n, right? So how many times are we allowed to perform the operation? So the answer to that is basically n by 2 GIF, or you can say n minus 1 upon 2, because n is odd. Like why is that so? Because you are decreasing the length of array by 2 every time. So initially it is n, or let's say n is 7, let's say. So initially it is 7, then it becomes 5, then it becomes 3, then it becomes 1. So it took 3 operations for the length to become 1. And in general, if I say I have n, then I have n minus 2. So of course it will take n by 2 steps to reduce down to 1, right? Since we are removing two elements at every step. Now what does this mean? That our maximum answer, like okay, in one operation we can, like basically in some element we are adding 1, like in one operation we are adding 1 to some element, right? So at max, what can be my answer? Like if the maximum element in the array, let's say it is m, the maximum element is m, okay? So ideally what I would like to do is I would like to add 1 to m every step, like m plus 1 it should become, then I perform the operation again, so it will become m plus 2, and so on. So at every step I should increment this m by 1. So finally my it would become m plus n by 2 GIF. So this is the ideal situation, where if I am able to do this, then it is always optimal to do this, because I can never get an answer more than this, right? Okay, but now how do we check that whether it is possible or not? right? That in every step we want to increase, we want to increase the maximum element, right? And since we want to increase in every step, that means um our maximum element, like, see, when I am doing the operation in an array, our maximum element out of these three should be either here or here, right? It cannot be in between. Why? Because then I would not be increasing, I would not be incrementing by 1 in this operation. But since we want to reach m plus n by 2 GIF, I need to increase 1 in each step. And also, one of these numbers should be the maximum element of the array, right? So till here, I think it should be clear that we want to reach m plus n by 2, which is the absolute maximum that we can reach in n by 2 steps, right? So to do that, we need to ensure that at every step, our maximum element is either here or here, right? So what can I do? Basically, I just need to choose two elements. Like, let's say my maximum element is here, right? So either I can do an operation here or I can do an operation here. Like, either we can do these three or we can do it on these three. In both of these cases, this m will increment. This m will become m plus 1, right? So basically, I can always increase an element. Like, I can always increase this m element by either choosing this one or choosing this one. But there is one case, like, okay, if the array length is at least 4, then I can do this. Like, if there are 4 elements, then I can either choose 3 elements to the left, or I mean 2 elements to the left, like this, or 2 elements to the right, right? But if if we have only 3 elements, let's say, in the array, then it is not always possible. Like, then it is not always possible to choose um, an array, the 3 elements, such that m is either the leftmost or the rightmost, right? Like, if m is in the middle, then in these three elements I cannot choose an a sub array. So basically, if after doing all of these operations, like, okay, I am starting with n length array, right? N length array, and let's say n is greater than 3, so it is at least equal to 5, right? So after doing the operations, eventually, like, okay, what operation will I do? I will ensure that every time m is getting increased by 1, m is getting incremented by 1. So eventually I will reach length 3, right? Like, till length 5 there is no problem. Till there is length 5, I am always possible, like, it is always possible to choose 3 elements such that m is either leftmost or rightmost. So we will choose that. But once we reach 3 elements, it may or may not be possible to choose um what? To choose these 3 elements such that m is either the first or last. So it is possible that m is in between. So in that case, we won't be able to increment it one more time. So in that case, the answer would just be m plus gif of n by 2 minus 1, right? Because in the first n by 2 steps, we were able to, like, increment that. We were able to increment this m. But at the last step, we are not able to increment this m. So the answer in that case would be m plus n by 2 minus 1. But now our question is that, in which cases will m land up at this position 1, and in which cases will m land up at either here or here? Like, that's what it remains, right? That if m lands up either here or here, then our answer is just m plus n by 2 GIF. And if our m lands up in between, then our answer is 1. Answer is this minus 1. So, but how do we determine that whether there is a possible sequence of moves such that we can reach either this element or this element? So how do we determine that? we can basically observe, what we can observe is that whenever we are doing an operation on m, let's say we have chosen this m and we are doing operation on this one. So either we do operation on here or either we do it on here, right? So let's say initially the index of m is I, then if we do operation on here, right, then what will happen that these two will delete and this will become m plus 1, but the index will remain same, right? The index will remain same if I apply this operation, and if I apply the lower operation, like if I apply this operation, then the index of this, if it was initially I, then it becomes I minus 2, right? So after every operation, either the index of element m remains I, or it becomes I minus 2. So that means what? That the parity of I does not change. What does parity mean? That whether I is even or odd. So if I is initially even, then it will remain even. And if I is initially odd, then it will remain odd over all the operations. So in the end, we can easily determine that whether m will lie on the first index like 1, or it will come to 0 or 2. Like if initially the index of m is even, then it can come to either 0 or 2. And if the index of m is initially odd, then it will come to 1. So that is the solution here, that we can basically find the maximum element, and if the index of that element is even, then the answer is m plus n by 2. And if the position of that or the index of that is odd, then our answer is m plus n by 2 minus 1. But there is one case, there is an edge case, that what if m occurs multiple times in the array, like the maximum element is there multiple times, like m here, m here, m here. So in this case, basically you will check for all the m's. Like if at least one has an even index, then of course you will choose that element and do the procedure using that element. Like let's say this one is at 0, 1, 2, 3, 4. So this m is at even index. So I will not choose this m, but I will choose this m to do my operations. So I will do first this operation, then I mean, and so on. Actually, this is wrong because n is odd. So yeah, this index. So 4, 5, 6, 7, 8. Yeah, so I will first do this operation, then I will do this operation, and so on. Like it will definitely end up in m plus n by 2. That is 9 by 2, which is equal to 4. So m plus 4 will be the answer in this case, right? So that should be clear, I think. So the solution is that. I hope everyone understood this. Did everyone understand? If yes, then please give me a yes in the chat. Please give me a yes in the chat. That if we find any occurrence of the maximum element on the even index, then the answer is m plus n by 2. Otherwise, our answer is m plus n by 2 minus 1. So did you all get this, guys? Okay. So I will show you the code quickly. So yeah, the code is pretty simple. I am taking int t c in t while t minus minus, int n c in n, int a of n. For int I equal to 0, I is an I plus plus, c in a of I. I just take the input of the array. Int ma is equal to star max element a comma m plus n. So this is my max element. This is the ma is the value of max element. Okay. Bool found equals to false. So I am iterating over the entire array, like on the even indices. On the even indices, I am iterating that I equal to 0, I less than n, I plus equals to 2. If a of I equals to ma, then that means that there is an occurrence of the maximum element on an even index. So I just set found equals to true, right? And if found, then I just print ma plus n by 2. And if I have not found the instance of maximum element at my even index, then the answer is m plus n by 2 minus 1. The odd case, can I please repeat? Okay. So if the index of the maximum element is odd, okay, so I'll take an example. Let's say maximum element is 5. So I have 1, 2, 3, 5, 4, 2, 3, because n is odd, right? So suppose this is my array. So maximum element is here, which is index number 3, right? So what is the problem in this case? Let's see. So first I will do what? I will try to do this to increase this 5 element, so it will become 6. So the array becomes 1, 2, 3, 6, 3. Then I will try to increase this element again, but there are not enough elements on the right side, so I will increase this using this side, so it becomes 1, 7, 3. But now I have to do one more operation, but the thing is that this 7 cannot be increased anymore, because there are not enough elements on the right side and on the left side, right? So in if my maximum element ends up at the index 1, like when my final length is 3, okay, when my final length becomes 3, uh, okay, so when my final length becomes 3, my maximum element should not be in the middle. It should be either at first or at the last, in order for us to in order for the answer to be n plus n by 2. Like if we want to increase by 1 in every n by 2 step, then our maximum element should end up in either the first or either index 0 or index 2. But if the starting index of this max element is odd, then it will always remain odd, because in each operation, after each operation, the index either remains I or it becomes I minus 2, right? So that's why in the odd case, I will not be able to perform the operation in the last step. Like in the last step, this 7 will not be incremented. So that's why only in n by 2 minus 1 steps. That means all these steps but the last one, I was able to increment. So my maximum value gets increased by this much. So this is the answer. Okay. So Conqueror's quest. Can you did you understand? Okay. So let's move on to the next problem. Shall we play a game? Yes, we shall. Okay. Alice and Bob play a game over n rounds. Starting with an initial score of 0, Alice takes the first turn. In the ith round, the current player must either add or subtract 2 to the power I minus 1 from the current score. Okay. As the game progresses, let x be the maximum score reached at any point, and y be the minimum score reached at any point. Alice's goal is to minimize the final difference x minus y, while Bob aims to maximize it. Assuming both players play optimally, determine the final value of x minus y after all n rounds. Since this value can be very large, output it modulo this number. Okay. So we have um sorry, yeah, we have this game where Alice and Bob play for n rounds. Okay. N rounds they play for, and basically in ith round what happens, like, okay, Alice starts, then Bob plays, then Alice plays, and so on. And what happens is, in the ith round, whoever's turn is it, either he can increase the current score. So initially score is 0. So whoever turn is it, he can either increase the score by 2 to the power I minus 1, or he can decrease the score by 2 to the power I minus 1. All right. And let's say the maximum score during this entire process is max, and the minimum score is min. Then Alice's goal is to maximize max minus min, or Alice's goal is to what? Uh, Minimize this max minus min. and Bob's goal is to maximize this max minus min. So what we can do? So the problem is that what will the final value be, assuming both the players play optimally, right? So that is our problem, and the value of n is up to 10 to the power 3, and test case is up to 10 to the power 3. All right. So let's observe one thing, that after each round, like in each round, the value that each player is adding is increasing exponentially, right? Basically, in the ith round, it is 2 to the power I minus 1. So initially it is 1, 2, 4, 8, 16. So it is increasing very rapidly, right? So actually, many things depend on what was the last move that was played. Like, because the last move is very large as compared to the all the previous moves. In fact, the sum of all the previous moves is less than the last move, if you can observe that. So like, if on the ith move, or let's say on the I plus 1th move, I add 2 to the power I, or I subtract 2 to the power I, um, up till here, the sum of these things, like 1, 2 to the power 1, 2 to the power 2, up to 2 to the power I minus 1, if you sum all of these up, then their sum will be 2 to the power I minus 1. So even the previous value's sum is less than the last element added. So my point is that it is increasing very exponentially, very rapidly, right? So our score highly depends on what was the last move. Okay. So basically, let's graph it. Okay. Let's say initially we are at 0. Now let's say Alice plays the move 1. Like, he first of all, she increases it by 1. So it will become 1, right? Then it is Bob's turn. So let's say Bob increases or decreases by 2. So let's say he decreases it. Okay. So it will be minus 1. Then Alice increases it, or Alice maybe decreases it again. So it will become minus 5, right? And so on. So this is like, my point is that, okay, this is the highest element, and this is the lowest, this is the highest peak, and this is the lowest peak. And my claim is that our current score will be either the all-time high or the all-time low. Like, if the last move was to decrease, okay, if the last move was to decrease this score, then our current score will be all-time low. And if our last move was to increase, let's say this, then our current score will be all-time high, right? That's what my point is. So is this clear, guys, why this is the case? Once again, my point is that, um, after the ith move, like, we need to add 2 to the power I minus 1, right? We need to add 2 to the power I minus 1. And this is a very huge number. Like, this is increasing very rapidly. So basically, till now, what we added? Till now, we added 1, 2, 4. I mean, added or subtracted. Either ways, 1, 2, 4, 8, up to 2 to the power I minus 2. And now we need to add or subtract 2 to the power I minus 1. So this is a huge number as compared to these numbers. Why? Because, like, even it is greater than the sum of all of these. Like, sum of all of these is 1 plus 2 plus 4 up to 2 to the power I minus 2. And their sum is basically 2 to the power I minus 1 minus 1. So this 2 to the power I minus 1 is even greater than the sum of all of these numbers. So it is a huge number. So my point is that, if, like, we have decreased our score by this number, then it will be all time low. Like, even if I even if let's say I keep increasing, like let's say on the first move I increased by 1, then on the second move I increase by 2, so it will become 3. Then on the third move I increase by 7, and on the last move, let's say I decrease by 8, right? So it will become -1, which is the all time low which is the all time low, right? Up till here the all time low was 8, sorry, 0 it was, and after I subtracted 8, the all time low became -1. So like, even in the worst case, when i when I was increasing, and then I decreased once, just once I decreased, even in that case it went past 0, right? So if I am doing something else, like let's say I am doing zigzag something, so let's say something like this, then it is even more obvious than that it will go even lower. So like, if we if our last move was to decrease, the score, then that score will be an all time low. What do I mean by all time low is that, from the starting to the current time, the minimum score is right now. Like, before this, no score, like our score hasn't been less than the current score. So did you guys get it now, that if my last move was to decrease, then this would be an all time low, and if my last move was to increase, like let's say I am doing some operations, let's say 1 2 3 4 5 6 and 7, then our like if our last move was to increase, then this would be an all time high, right? So basically, what can I say? I can say that if the current range, like if my current range of values, or let's say my current min comma max, it is something. So like, let's say it is a comma b. Let's say if my min comma max is equal to a comma b, then my current score is equal to either a or b, right? So this is the thing, that's my point, right? Now Alice basically wants to minimize the difference, right? Maximum final difference. So what Alice is doing, Alice is trying to minimize. So let's say we are currently somewhere, Alice increased, then let's say Bob decreased, then let's say Alice also decreased, then let's say Bob increased. I am not saying that this is the optimal move order, but this is one of the possible move orders. So right now it is Alice's turn. So the all-time low was this, and the all-time high was this, right? Okay. So guys, now let's say she wants to minimize. She wants to minimize the um the difference between max minus min. Then will she decrease or will she increase? That is my question to you. Like, currently, after this, should she increase or should she decrease? Tell me, guys. She should decrease, right? Why? Because that will kind of lower her score, or like, in out of the both scenarios, the lower score will be obtained in this one. I mean, the lower difference will be obtained in this one. Like, if I increase it from here, So this is one possibility, right? But the better option is to decrease it. So now this is the difference. Okay. So essentially, what is this difference? This difference is 2 to the power I minus 1, right? 2 to the power I minus 1. Like on the ith move, if I do, I had to subtract or add 2 to the power I minus 1. So I subtracted 2 to the power I minus 1. So this difference becomes 2 to the power I minus 1. Right. If I had actually increased it, let's say I had increased this, right? Then this is 2 to the power I minus 1, right? And in fact, this is 2 to the power I minus 2. So our final max minus min in this case would have been 2 to the power I minus 1 plus 2 to the power I minus 2, right? So that's why LS should decrease. Like if currently we are at the maximum, then LS should decrease. And if currently we are at the minimum, let's say we are doing something and we are at the minimum. Sorry, this is not correct. Let's say we are at the minimum, then LS should always increase. LS should always increase because when she increases, this will happen, and the max minus min difference would be 2 to the power I minus 1. And if she had decreased instead, then her value would be, if she had decreased, then the value would be 2 to the power I minus 1 plus this difference, which was 2 to the power I minus 2. Right. So in summary, like this is, I spoke too much. I mean, I think so. The summary is that if Alice is currently at the minimum, then she should increase, and if Alice is at the maximum, then she should decrease. Okay. And the reverse for Bob, right? The reverse for Bob, because he wants to maximize the difference, right? He wants to maximize the difference. So let's say something is happening and he is at the maximum right now, right? So what he will do, he will increase it even further, right? So he will increase it. So this will become something like this. The the difference would become something like that. And if currently we are at the minimum, right? Currently we are at the minimum, then Bob will decrease it even more, right? So after knowing all of this, we can easily solve the problem. How? What will we do? We will just try to simulate what will happen. Okay. So initially the score is what? The score is 0, right? Now let's say Alice increases, like without loss of generality. Let's say Alice increases by 1, right? Then what will happen? Bob will decrease. I mean, wait, sorry, Bob will increase again because we are at the maximum right now, right? This is the maximum, this is the minimum. So it is Bob's turn right now. So Bob will increase it even more. So this will become 3. Now it is Alice's turn. And we are at the maximum, so Alice will decrease it. So she has decreased it by 4. So it has become -1. So the diagram is pretty misleading. Uh, Wait. Yeah, so this becomes -1. Then it is Bob's turn. So what he will do, he will decrease it even more. So it will become um, what? -9, because he will decrease by 8, and so on and so forth. Like Alice, now it is the minimum, so Alice will increase, right? Now it is the maximum, Bob will increase also, Bob will increase once more, and so on. So that is what happens here. And according to the value of n, we can definitely find out the answer. Like what I did was, I just simulated the process. Like actually my code is pretty messy, so I I won't show it to you, but like I will tell you another like elegant logic of this, right? So this is what will happen, that if n equals to 1, then it is Alice's turn, and this is the answer. If n equals to 2, then it was Bob's turn, and 3 is the answer. Then if it was Alice's turn again, like let's say if n equals to 3 was there, then the answer would be this thing, right? And if it was Bob's turn, then the answer would be this. So like this plus this. So my claim is that, okay, if n is odd, if n is odd, right? If n is odd, then the last move would have been of Alice's. Like, let's say I color code this. Uh, just a minute. Yeah, so let's say, wait. So this was Alice's move, right? This was Alice's move. Then this was Bob's move. Then again, this was Alice's move up till here. And this was Bob's move, right? So whenever it ends with Alice's move, our maximum difference is what? Like let's say it ends here. Okay. So our maximum difference is what? This is the minimum and this is the maximum. So our answer is this. That what is the last move that we performed, which is basically 2 to the power n minus 1. Right? And if our last move was performed by Bob, then our answer would be this last move and also the second last move. Like our final answer is this range, right? From here to here. So this last move plus the second last move also. Okay. So 2 to the power n minus 1 plus 2 to the power n minus 2. That is the answer. So the final solution is like if n is odd, then the answer is 2 to the power n minus 1. And if n is even, then the answer is 2 to the power n minus 1 plus 2 to the power n minus 2. Okay. So I think this should be clear. Or if someone has a doubt, then they can ask. Clear? Okay then. So I'll move on to the next one, or I'll attach the code in the description. Like this code is pretty simple, right? And actually I don't have the code right now, so I will send the link in the description. Okay. So let's move on to the third problem of the day. It is called easy. Okay. Chef wants to construct two special strings S and T of length n using only characters A, B, and C for a coding challenge. Both strings must satisfy no two adjacent characters are same and their LCS is exactly k. So the length of LCS is exactly k. Right. Chef needs your help to determine if it is possible to construct such strings S and T. If it is possible, then output the strings, otherwise output -1. Sujit, the code I will attach in the description because I don't have it right now. And it is pretty easy. You just take the input of n, and if n is odd, then print 2 to the power n minus 1 modulo that value, modulo mod, right? And if n is even, then print this value modulo that mod. Don't forget to take mod every step. Okay. Yeah, so we need to find out two strings such that no two characters are same, like side by side. No two characters are same, and their LCS is equal to k. Okay, so we have string s, we have string t. Like we have to construct the string s and string t such that their length is n, length is equal to n, and we have to make sure that si is not equal to s of I plus 1 and ti is not equal to t of I plus 1 for all I. And also we have to ensure that the length of LCS of s and t is equal to k. We have been given as input n comma k, right? So we need to construct this, right? Now actually, while giving the contest, um, I did not prove this, right? I mean, what I just did, I just thought that when would minus 1 come? Like I wondered, right? And to figure that out, what I did was just I just wrote a brute force code. Like I just wrote a brute force code which generates all possible strings of length n. Okay. And I compared like all possible strings which have ABC, and no two characters are same on the side by side. Like s of I is not equal to s of I plus 1. So I generate all those strings, and for each pair, I calculate their LCS. Their LCS I calculated. So this is I'm just doing brute force, right? I just did a brute force, and I checked that how many values, like for what k is it satisfying, like how many k's are coming, how many different k's are coming. Okay, so what I observed was for 1 it was like 1 0 was possible and 1 1 was possible. Then I observed that 2 0 wasn't coming, like in no strings of length 2 LCS was 0, right? So 2 0 wasn't coming, but 2 1 and 2 2 were coming. Then for 3, 3 1 was coming, 3 2 3 2 was coming, and 3 3 was coming. Then for 4, 4 2 was coming, 4 0 4 1 was not coming. So 4 2 4 3 and 4 4, and so on. I printed till length 8. Okay, I printed till length 8, and I observed that for k less than floor of n by 2, it was not possible to have an LCS of k. Like since the constraint is that the adjacent elements should not be same, right? So actually that is a pretty tight constraint. Like it is very difficult to make. Suppose we want to make string of length 5, and we want only two letters to be common, like their LCS should be 2. Then it is pretty difficult because we have only 3 letters, like A, B, and C. So let's say I try to do something like A, B, and A, and I try to do something like in this one, I don't put A's but I put B's. So C, B, C, B, C. Okay, so floor of 5 by 2 is 2, right? So it is possible. But let's say we want only one common character. LCS is 1. Then it is not possible at all. Like, let's say if it was not like the constraint was not like that we did not have this constraint, then we could make all of the characters. Like for any k, we can construct an answer. How we can do that? We can just print a k times, like a and so on, and then rest we print b, and in the other string we print a k times, and then we print c's. So this is the LCS of these two strings, and it is of length k. But it is not possible to do this in due to this constraint. And I observed using my brute force code, I observed that it is not possible to like have k less than n by 2, right? K less than n by 2 is not possible, and actually I will prove it to you guys also. Like of course, if some of you don't know, like of course we need to prove it, right? I just observed it using my code, but how do we prove this? That for two strings s and t of length n, if I have two strings s and t, then it is not possible to have LCS less than n by 2 if no two characters should be same side by side. So how do we prove that? We can basically prove that by looking at blocks of 2. Okay, so let's say I have this string s0, s1, s2, s3, s4, and I have s t0, t1, t2, t3, t4, and so on, like up to sn minus 1, up to tn minus 1. So now look at these first two letters, guys. Look at these first two letters of each string, right? We have only three letters, A, B, and C. So, and here these are four letters, right? These are four letters. So, by using pigeonhole theorem, we can say that either one of, like, at least one pair among this is same. Like, out of these four characters, at least one character is same. Like, at least one character occurs twice. And also we know that these two are not same, right? These two are not same. So that's why we know that either this is same, like out of these four pairs, either this or this, either one of this is same, because we know that these two are not same, right? So basically we can just select that character in our subsequence. Like let's say s0 and t1 are same, then we can select this as the common letter. So I have one from, let's say I have one letter from this, then I will do the same thing for these four letters. Let's say these two are same, so I'll choose these two. So in total there are floor of n by 2 blocks, right? GIF of n by 2 blocks. Like this is one block, so there are in total n by 2 blocks like this. So I can, like from each block, I can select at least one letter in my LCS. So that's why the length of LCS is at least n by 2. K greater than equal to n by 2 should always be there. So do you all get this part? Guys, do you all get this? That why K has to be greater than n by 2? Greater than equal to n by 2. If there is some doubt, then I will explain again. So do I need to explain again, or is it clear? So I am not receiving any response. So I am assuming that it is clear. Okay. All right. So yeah. So basically, for first part, that if k is less than n by 2, okay, then our we'll just print minus 1. It is not possible, right? Just print minus 1 and done. But now let's say k is at least n by 2. K is greater than equal to n by 2, right? And you want to construct two strings s and t which have LCS equal to k and satisfy this constraint that no two characters should be same, right? So how do we build this? We have only three characters, A, B, and C, right? So in order to build this, what can we do? Basically, we can do something like what? Let's say I want to build f exactly n by 2, okay? Exactly n by 2 characters I want to be common, or LCA should be n by 2. So what can I do is I can do it this way, that A, B, A, B, A, B, A, and so on, right? And here I do C, B, C, B, C, B, C, and so on, right? So in these two characters, the only common subsequence or the LCS is basically these B's, right? These B's are the common subsequence. And how many B's are there? There are exactly n by 2 GIF B's. So that's why the LCS of these two strings, S and T, is equal to n by 2. Okay. So, right. So now we have how to create n by 2. But let's say our k is greater than n by 2. Like, okay, less than n by 2, the answer is minus 1. If it is equal to n by 2, then our answer is this. But let's say our answer is greater than n by 2. Like, let's say it is n by 2 plus 2 or something. So, in that case, what can I do? I can just replace these two C's with an A. I can replace two C's with an A. So, in that case, these two A's will also be a part of my LCS. Right? So that's a construction. Like, pretty simply, we can do this. N by 2 plus 2, like whatever is the difference between k minus n by 2, we can just replace those c's with a's. So in that case, the LCS length would be k. So that's the solution. Is it clear, everyone? Okay, thank you, Prince. So I'm assuming it is clear to all since there are no doubts. So I will show you the code, of course. Submissions. Yeah, nk, c in nk. If k is less than n by 2, I will print minus 1 and return. For int I equal to 0, I less than I plus plus. This is my macro that I defined over here. If I is odd, then I print b, otherwise I print a. So I am not even storing the strings, I am directly printing s and t. So I am printing a b a b a b a b and so on, right? So my first string is a b a b a b a b, irrespective of whatever there is. Then I print new line. Then I need to print these many a's. K minus n by 2 a's I need to print. So I just do for int I equal to 0 as an I plus plus. If I is odd, then I print b. Otherwise, if count is non-zero, then I print a and count minus minus. And if count is 0, then I print c. So this basically prints a b a b a b, then c b c b c b c, and so on. Like the k minus n by 2 a's will be printed, right? And then I just print new line, and that is done. Okay. I hope it should be clear. Okay. So I'll move on to the next problem. That is the last of today. This is called counting problem. You are given an array A of an integers. Uh, some of the elements in the array are missing and are represented by the number minus 1. You need to replace each missing element with an integer from the range 1 to k. For each possible valid array, let f of a denote the number of non-empty, strictly increasing subsequences of the array. Your task is to compute the sum of fa over all possible valid arrays. Since the answer can be very large, output it modulo 998244353. Okay. So we have an array, right? We have an array of n elements. Okay. But we don't remember some elements. So they are minus 1. So let's say 2, 3, minus 1, 4, minus 1, 5, 6. They are minus 1. So basically, we can replace these minus 1s with any element from the range 1 to k. Okay. And then what we can do is, we can, like, basically for all the possibilities, like let's say there are um, v number of minus ones in the array. So here v equal to 2. Like there are v number of minus ones in the array. Then there are k to the power of v possibilities of our new array, right? Of our new array, there are k to the power v different new arrays, because there are k possibilities for every minus one, and there are v minus ones. So out in all of these arrays, we have to print the sum of f of a, right? And what is f of a defined as? F of a is defined as the number of non-empty, um, strictly increasing, strictly increasing subsequences, of the array. Okay. And so we want to find the summation of f of a over all possible k to the power v arrays. Okay. And the constraints are actually allowing, like, they are pretty low. Okay. Where n is up to 5000, k is up to 5000, right? So they are allowing n square, right? Or n into k also they are allowing. And this increasing subsequence, this subsequence, like these numbers n into k, all of these facts suggest us that we need to use dp. Like, it is kind of intuitive that there is a hidden dp solution. Okay. So let's think about dp, right? That's how I thought about this, that n into k, strictly increasing subsequences. So all of these terms are kind of many very common in dp solution, right? So let's think about dp. So what will be our state? Let's think about that. Okay. So our state can be dp of ij. Let's say I is the index. Okay. I is the index that we are currently on, and j is the value of the current index. J is the value, which means a of I. Like, because on some indices the a of I is minus 1, right? So it can take any value. At this index, it can take any value. So I am including a state for the value as well. That what value am I choosing to keep there on the ith index? So that is the value. Okay. So let's say at some index I, at the ith index, if my input, like if my input array arr of I, it is not equal to minus 1, let's say it is equal to some number, let's say 3, then my dp of I comma 3 would be non-zero, and all the others would be 0, because I cannot have any other element except for 3 on the ith place. So my dp of ij is that I am at the currently index I, and my element at the index I is j. Okay. And what am I storing in dpij? I am storing that, considering only the first I elements. First I, like considering only elements till index I. If I consider only those index till the index I, and like value is j at index I, then, like, basically I'm storing the number of subsequences, ending at I. Okay. This is my DP. Like what I am storing, essentially what I am storing is the number of subsequences. The final verdict is this. Wait. So for some reason this hangs or something. But yeah, my DP I am storing as a state. Like okay, as a state I have that on which index and what is the value in that index, and what I am storing is the number of subsequences, basically number of subsequences ending at I. This is the most important part. Okay, like considering only the elements till index I and the value is j at index I, then what is the number of subsequences ending at index I? That is my DP. That is my DP of ij. Okay, and finally what I have to do is I have to calculate the, like I have to calculate sum of fa, right? Sum of f of a I have to calculate. So essentially what would that be? That would just be the summation of dp of ij, right? Because ending at I, and like if we want ending at this dp of ij stores that ending at I, right? And j stores like that element and index I is j. So I need to take the sum of I equal to n minus 0 to n minus 1 and j equal to 1 to k, because the elements can be from 1 to k of dpij, and this is the answer. But actually this is not the answer. Okay, yeah, not the number of sequences. The number of subsequences were increasing. Actually, my bad. The number of increased subsequences we store. The number of increasing subsequences at I, ending at I. That is what we are storing. That considering only the elements till I and value j at index I, then the number of increasing subsequences ending at I. That is our dpij. So our final answer that would be j equal to 1 to k, I equal to 0 to n minus 1 of dpij. But actually this is wrong. Like this is what we initially would think, but this is actually wrong. Why? Because let's say till here, like let's say there is an index which has 1 here. Okay, this is our array and which is 1 here, and there are some elements here. We don't care about that, but we just know that this dp of 4 comma 1, like this is index, right? The index 0, index 1, index 2, index 3, index 4. Let's say dp of 4 comma 1 is equal to 5. What does that mean? That there are 5 subsequences which end at 1. I mean increase subsequences which end at 1, right? So but actually if there are, let's say, minus ones here also, like in these two indices, if there are minus ones, let's say minus 1 is here and there is some constant value here, so we would have to multiply it once more by k also. Like by one more k we would have to multiply it, because um basically this subsequence, like let's say we have one subsequence which is okay, let's say there is 3 here, not 1. Okay, there is 3 here and dp of 4 comma 3 is equal to 5. So let's say one of the subsequences is 1 and 3. Like out of this 5, one of them is 1 comma 3. And actually we have considered the contribution of some minus ones here also. Like let's say there is minus 1 here. Then we have counted that. Like basically we have counted this 1 comma 3 twice. Because I sorry, twice, not twice. We have counted it k times already. Like in my dp of ij, it is incorporated already that these minus ones will multiply my answer. Like wait, I'll give an example much more clearly. Okay, this is pretty useless. I will make one my example. Okay, so let's say we have 1, -1, 2, and -1. Okay, this is our input array. Okay, so guys, what is the DP of 2 comma 2? So this is the index. Index is 0, 1, 2, and 3. Now my DP of 2 comma 2, what should it be? Basically the number of increasing subsequences ending at 2. So what would that be? And if we consider only these first three elements, that's my point. Just ignore this -1 for now. If we consider only the first three elements, then the number of subsequences ending at 2. So what would that be? One of it would be just this 2, like just this 2 alone, right? And let's say k was equal to 3. Okay, k equals to 3, assume. So one of the subsequences would just be this 2. Then one of them would be this 1 comma 2, and one of them could be what? If we place, let's say, a 1 here instead of -1, if we place 1 here, then it can be this 1 comma 2, like this one 1 comma 2. And if we place, okay, for clarity I'll also write the index. All right, so the index of this is 2, the index of this is 0 comma 2, and this is 1 comma 2. Okay, yeah, so basically our answer is 3. But my point is that our DP of 2 comma 2 will not be equal to 3. Like even though there are three arrays, there are three subsequences which are increasing, which end at 2. I will not store 3 in my I'll not store 3 in my DP, because this 1 comma 2, like this thing, will occur in three arrays. Like if I consider only the first three elements, then how many possibilities are there? Either it can be 1 1 2, or it can be 1 2 2, or it can be 1 3 2, right? So there are three possibilities to substitute this -1 in place of some number when k equal to 3. So there are three possibilities for doing this, and this 1 comma 2 subsequence occurs in every one of them. So we need to count them three times, right? And also this 2 wala subsequence also occurs in all of these three. So we need to count this 2 subsequence three times. So this one will be counted three times. This also will be counted three times, and this one will be counted only one time, because this occurs only in the first one, right? So our DP would be 7. The value of DP would be 7 in this case. Okay. So Prince, is it clear? You are saying, like, is this clear that what am I storing exactly? What I am storing? I am storing the 7. Like I am counting that how many times it occurs, that as well. But I am not. I am ignoring this -1 for now. Like considering only the first, like only the element up to I. I am considering only the element up to I. Okay. So Prince, is it clear? And everyone else also, is it clear that, yeah, you ignored -1? Correct. So that's why I am storing 7 in this. But the thing is that even if I am doing it like this, doing summation of dpij is actually not correct. It is not correct. Why? Because we are not considering this -1. Like let's say we just count that how many end at 2. So we have our DP as 7, right? So we would say that 7 subsequences are increasing and end at 2. But the thing is that we need to multiply 7 by one more 3, because this -1 can be anything. Like this -1 can be either 1 or 2 or 3. And in all of these cases, we will still have, like in each case, we will have 7 subsequences using the first I elements or up to the index I, right? So how many minus ones are there? Let's say there are v minus ones. There are v minus ones. Then I would have to multiply this dp of ij by k to the power v also. Multiply this vij by k to the power v, k to the power v, right? And that would be my final answer. My final answer would be that the summation of dpij into k to the power v of I, where v of I stores that how many minus ones are there after ith index, right? So guys, is that clear? That if I suppose I am assuming that I have calculated this dp of ij, then my final answer would be dp of ij into k to the power v of I and the summation of that, right? So that is what I have done in my code. But yeah, of course I'll tell you that how to calculate this dp of ij, but I'm assuming that let's say I have already calculated it, then what is my answer, right? So I'll show you I have done that also. Just ignore these submissions. So yes, so I have done the dp here in this part, and in the end I am counting this, that how many are minus 1 in the suffix of this, and finally what I am doing is answer plus equals dp of ij into k to the power v of I, and I print the answer. Now how do we calculate the dp? That is the main question here, right? So okay, let's think about what is dpij. The dpij was the number of increasing subsequences ending at I and a of I equal to j, right? This was our dp. So let's say we want to count this, that I want to include this element I, like on the ith position I have the element j, right? So how many subsequences, that is increasing subsequences, that can we have till here? We want to calculate that, right? So actually what we can do is we can basically transition. How? Like basically I want that my last element is this ith element and it is j. So just previous to that, what can be? Like it can be any element from 1 up to j minus 1, right? 1 to j minus 1. So and also I can come from any index. Like let's say there was some j minus 2 here, and this is some j here, and this is some index k. So I can add, like I can transition from here also. I can transition from this point to this j. Like, are you getting me? Like, just ignore this minus ones for now. Like, just assume that there are no minus ones in the array. Then how would you calculate this? Like, how would you calculate that how many subsequences are there which are increasing, right? So to do that, basically dp of ij would just be equal to, like let's say we are transitioning from some index k, or k is taken actually, so let's not do k. Instead of that, let's say it is I dash, and here the value is j dash, right? So let's say we are transitioning from I dash to j dash, so we would just add this to our answer. Like basically dp of ij would be the sum of all dp of I dash j dash, like I dash equals to 0 to I minus 1, and j dash equal to 1 to j minus 1. Like if there are no minus ones, basically, assuming that there are no minus ones in the array, we can just take any subsequence ending at I dash which has value j dash, and we can append this I comma, like the element at index I, at the end of it, right? So that's why the number of subsequences ending at I is equal to this, and j is equal to 1 to j minus 1 because we want that the last element, we want the sequence to be increasing, right? We want the sequence to be increasing, so that's why I am iterating from j dash to 1 to j minus 1. So till here is it clear, guys, that if there are no minus ones, we can write this thing, that dp of ij equals to this. So is it clear, guys, like how I got this thing? Yeah, this is fine. But now let's say we have minus ones. Okay, so let's say again take an example that I have 1, minus 1 and 2, right? And let's say k equals to 3 again, and I want to transition from this 1 to this 2. Like basically I am calculating dp of 2 comma 2, and I want to calculate this using this one. Like I am considering the contribution of this one. Like I am calculating that whichever sequences end at 1, if I append a 2 to them, right? So ideally what would I just do? I would just do plus equals to dp of 0 comma 1, right? But here actually I have to take this subsequence 3 times, like because there is a minus 1 here, right? So this 1 comma 2 subsequence, 1 comma 2 subsequence will occur dp of 0 comma 1, like the number of times this 1 wala occurs, multiplied by k, because I can keep any value here in place of minus 1 and it works. So basically, um, suppose there are v minus 1s in between those, like there is 1, there is minus 1, there is minus 1, then there is 2, or there is 3 and there is 2. Okay, and I want to transition from this 1 to this 2, that is I want to calculate the dp. The index is 4, right? And the index is 4, so I calculate dp of 4 comma 2. So I can do dp of 4 comma 2 plus equals dp of 0 comma, like 0 comma 1 multiplied by k to the power 2, because I can have k options here and I have k options here, and doesn't matter what I keep there, because I am not even choosing that element in my subsequence. I am choosing only 1 and 2 and the elements before 1 maybe, because but that is incorporated in this dp of 0 1 only, right? Like let's say there are minus ones before this one also, there are minus ones before this one, but that is incorporated in this dp of 0 1 only. We want to um, just incorporate these minus ones when we are updating our dp of 4 comma 2, right? So basically if we are like if we are transitioning from dp of I dash comma j dash to dp of ij, right? That is we are basically doing dp of ij plus equals to dp of I dash j dash. We have to multiply it by k to the power number of minus ones between I dash and I, number of minus 1 between I dash and I, right? So this is a transition here, but actually if you notice that what is the complexity of this approach, Like, what is the TC and SC of this approach? The TC and SC. So SC is actually what? N into K, because we have N into K states, right? But the TC is actually N square into K square. Why N square K square, you ask? Because when we want dp of ij, we have to sum till I dash equal to 0 to I minus 1 and j dash equal to 0 to j minus 1. So basically, this is an n square transition or n into k transition. So n into k transition time on an average. So our TC is n square into k square. Prince, not n into k. It is n into k into k, because while transitioning also we have two loops, right? So that's the thing here. That's the issue that we are facing. Why k square? Because um, this loop runs from j equal to 1 to j minus 1, right? So this is basically, I can say, a loop of k, because remember j was the value, right? And the value can be from 0 to k, right? And I can say that this is a loop of n, because this is the index. So transition time is n into k. Transition time is n into k, and the number of states also, it is n into k. So time complexity is number of states into 1 plus transition time, right? Number of states into transition time. So that becomes n square into k square. So anyways, it is too slow. Both are too slow. So how do we optimize this? Let's think about that now. That how do we optimize this approach? Okay. So first of all, let's ignore this thing. Like, we want to inc- we want to do what? dp of ij plus equals dp of I dash j dash into k to the power number of bits between I dash and I. We want to do that, right? But let us just ignore this for now. Let us just ignore this part for now and think about how would we have done this thing. Like, let's say our transition was this thing. So even in that case, it would take n square and k square time. But how do we optimize that? Let's think about it, right? So in order to optimize this n square into k square, and basically when I am at I comma j, when I am at I comma j, I'll make a grid, okay, to visualize this more clearly. Uh, we have this, yeah. So let's say this is the ith row and the jth column, and we want to calculate this dp of ij, and we want to basically, the answer is what? The answer is the summation of I dash equal to 0 to I minus 1 and j dash equal to 1 to j minus 1 of dp of ij. Like ignoring that part, ignoring this part for now. So how would we transition? It is basically the sum of this part, the sum of all of these cells. If I say, yeah, second, yeah, sorry about that. Yeah, so my value of this dpij is basically the sum of all of these cells up to I minus 1 and j minus 1, right? I mean, the sum of this part, essentially. The sum of this rectangular grid is my dp of ij, right? So to calculate this, actually, we can easily maintain some prefix sums, right? We can just maintain some prefix sums, and we can easily transition this in O of 1, right? Do you all know this? That basically just maintain a prefix sum array which stores the sum of each prefix. Like, let's, like, prefix of 1 would store, okay, wait. Prefix of 1 would store the sum of this thing. Prefix of 2 would store the sum of this thing. Then prefix of 3 would store the sum of this thing, and so on. So let's say I want to transition up to into dp of ij, then that would just be equal to prefix of up till here. So up till here, whatever the prefix is, that is up to j minus 1. Prefix of j minus 1 I will add. So that's how I can transition is in O of one time. Like basically what we'll do is we can fill all of these cells. We can fill all of these cells using our dp, using our prefix sum. Like our prefix sum, see, when we have reached to this row, that means we have already calculated the dp for all of these, like these rows, and I have calculated the prefix sum up till this row. Okay, now what I'll do, I will calculate the dp for this row, right? And then I have to update the prefix sum also, right? So to do that, just take the prefix sum of this row along this row and add that to our previous prefix sum, right? And that's how you can update the prefix sum to include this row as well, in order for us to transition in this row. Like that's what our procedure will be. That first we will like calculate the dp using our prefix sum, then we'll update the prefix sum. All right. But now let's say we don't ignore that part. We want to incorporate that also. That k to the power number of minus ones between I dash and I. Right. So how do we incorporate that? And basically to do that, we can write this in some other way. Okay. So dp of ij is equal to dp of, so basically summation summation I dash equal to 0 to I minus 1, sorry, j dash equal to 1 to n minus 1, 1 to j minus 1, dp of I dash j dash multiplied by k to the power number of minus ones, between I and j, I mean sorry, I dash and I, the number of minus ones between I dash and I. So actually we can write this as in the form of prefix. Like let's say the number of minus ones from 0 to I dash is equal to p of I, or let's say it is equal to count 1, or okay, let's say it is p of I dash. Okay, so number of minus ones up to like from 0 to I dash, it is p of I dash. Okay, or let's say number of minus ones, wait, yeah, let's say the number of minus ones, yeah, so the number of minus ones from 0 to I dash minus 1, let's say it is p of I dash minus 1, p of I dash minus 1, and the number of minus ones from 0 to I, that is equal to p of I. Okay, so what we can write this as, we can write this as k to the power p of I minus p of I dash minus 1, k to the power p of I minus p of I dash minus 1, right? We can write it like this. And actually um, this summation, like this is multiplication, right? This is product, and this summation only iterates over I dash and j dash. So I can take out this k to the power p of I as common, right? So I can write this like k to the power p of I into something, right? My dp of ij would be k to the power p of I into summation I dash equal to 0 to I minus 1, summation j dash equal to 0 to j minus 1, and dp of ij into k to the power minus p of I dash minus 1. Okay, this is my transition now, that my dp of ij equals to k to the power p of I into this summation right here. And as you can see that this dp of ij into k to the power minus p of I dash minus 1, I can just write this as some variable, like I can just write this as some f of ij, right? And essentially what I want to do is just take the summation of j dash, sorry, f of I dash j dash, right? Because this is just a function of I dash and j dash, right? So I can call this f of I dash j dash, and I want j dash equal to 0 to j minus 1 summation I dash equal to 0 to I minus 1, and we want summation of f of I dash j dash. And just how we did the above transition, like basically just like we did summation dpij by using prefix sums, we can calculate summation of f of ij also. Like we can just store this in a prefix sum. Like instead of storing dpij in a prefix sum, we will store this f of ij in a prefix sum, and then we can easily transition by doing this prefix of j, by doing prefix of j minus 1. So it will give us this entire sum, and we'll multiply it by k to the power p of I. All right. So that's how we can transition in O of one time. So guys, is that clear? Actually, one minor mistake I did here. The formula is not k to the power number of minus 1 between I dash and I. It is number of minus 1 between I dash plus 1 and I minus 1. Right? Because at I dash, we need j dash. The value should be j dash. And at I, we need j. So in between them, it can be whatever. But at those two indices, it cannot be whatever. It has to be I dash and, sorry, j dash and j. That's why we count the number of minus ones between I dash plus 1 and I minus 1. Right? That is the error here. So yeah, the formula changes slightly, that it will become dp of ij into, it will become k to the power p of I minus 1 into dpij to k to the power p dash of I minus p dash of I minus p of I dash, sorry. All right. So summarizing it, like I will try to summarize my approach very, very quickly. That my dp of ij stores the number of elements. I mean, it stores the number of subsequences which end at I, such that the value of element I is j, and it is the increase subsequence, right? And to transition, we can basically iterate over all the indices which are before I. So let's say I dash, and we can append I to that. Like we can include I into this if and only if this j dash that is here, that should be less than j, right? So we will do dp of ij plus equals to dp of I dash j dash for I less than I dash and j less than j dash. But this is too slow, and also it is wrong. So why it is wrong? Because we have to multiply k to the power the number of minus 1 between I dash plus 1 and j and I minus 1. Multiply this as well, and it is too slow because it is O of n square into k square. And to optimize this, we can take this k to the power prefix of I outside, or I minus 1 outside, and in inside, like inside, the summation will remain the dp of I dash j dash into k to the power p of minus p of I dash. So we can assume that this is some function of I dash j dash and take its prefix to efficiently transition into dp of ij. Okay, so is this clear, everyone? And our final answer, I told you, final answer would just be summation of dp of ij multiplied by the number of minus ones, sorry, k to the power number of minus 1 after index I. Right, guys? This is my final solution. This is my final answer. And summation from I equal to 0 to n minus 1, j equal to 0, sorry, j equal to 1, n minus 1 to k. I mean, this notation is not correct, the summation notation, but never mind. But yeah, this was the method. So is this clear, everyone, or do I need to explain more? Do you all have any doubt? How do I think this much in contest? It is just because of practice. Like this DP solution was actually very standard. If you might like, if you have done many DP questions, then all of the ideas that I used here have been used in other problems. Like one idea which was prefix sums has come many times, and this other idea of keeping dpij as our state, that the last element is I and the value is j, that have also, like even in lis problem, lis we don't keep state like this, but it is kind of same. Like there are, like basically practice se ho jayega. That's what my point is. Okay, so if it is clear to you all, then I'll show the code. Okay, so yeah, solve functions int nk scene nk, and also I have like pre-computed the powers and the inverses. Like po of I stores k to the power I, and inverse of I stores k to the power minus I, because I was getting TLE. Okay, I got TLE many times. So I am storing this, like pre-computing this, and then what will happen? Like yeah, so, and yeah, I have this mint struct which automatically takes a mod for me. Like I don't have to remember to take the mod; it automatically does it for me, right? So I have this. So p of I equal to p of I minus 1 into k. Power of I, k to the power I equal to k to the power I minus 1 into k, and k to the power minus I equals to k to the power minus I minus 1 divided by k. And this division operator is overloaded by the mint struct. So when I do this division operator, it uses the modular inverse thing. Okay. Then I input the array and I initialize the dp of n comma k plus 1 size. dp of ij equal to answer if a of I equal to j, ending at I, and increasing subsequences. And pr, this is the prefix sum. Like pr of I is the prefix sum till I minus 1. Like let's say currently we are at this row. If we are currently at this row, then pr of I will store all of, or let's say pr of j. This is, if this is this column j, then pr of j will store all of these things. Okay, and pr of 0 stores 0. Then I have this total count, which I don't know why I have. I have not used it anywhere, so ignore that. And count equal to 0. This count is basically the number of times -1 has appeared. So basically the prefix of this. So I had this p of I, right? I had using this. I had been using this p of I, or p of I minus 1. So this count variable stores that. I don't have the entire array. While I'm iterating from left to right, I'm just maintaining the prefix sum of the number of times that one -1 has occurred. Okay, so I iterate from 1 to n, 0 to n minus 1, I mean. Now if a of I equals to -1, that means I can insert any value at this ith index from 1 to k. So I iterate from 1 to k, and if I want dp of ij, so if I want the value j here at index I, then it would be 1 plus prefix of j. Actually, yeah, 1, because we can also keep it like, we can also keep the only index I. Like if I want, just a minute. Yeah, so if I want dp of ij, that means increasing subsequences ending at I. So that can also include just single element I, right? Just single element I. So to count that, I'm adding 1. So either I transition from some previous element, or I start and end it at here only. So single element. So it is 1 plus prefix of j into k to the power of count. That is how many -1s have appeared till now. Because I mean that's the formula, right? That ans plus equals, or sorry, dp of ij equals to summation, or wait, this is wrong. Yeah, here it is. dp of ij equals to k to the power p of I minus 1. That is before ith index into this summation. So summation is stored by this prefix of j. And also the plus 1 will also come here. Okay. So plus 1. Right? So this is for all ij. And if a of I equals to not -1, so if there is some number there, then for every other number the dp is 0, right? Like we cannot have that number there, so the dp is 0. So for j equal to 1, j less than k, j plus plus, I just do dp I equal to 0, and dp of I comma a of I. So whatever number is there, it can be there. So dp of I comma a of I is prefix of ai plus 1 into k to the power count. So basically same thing here, but instead of j I have a of I. Okay, then so yeah, this is the first step to update the dp for the ith row, and then I'll update the prefix sum, right? So I'm making a temporary prefix sum which stores only for row I. Like for the current row, it is storing the prefix sum. So what it is storing, basically, let's say we have these rows and we have these columns, and let's say we are at this row right now. So temp of I stores this sum, up to the ith index, or the I minus 1th index. So this is index I, then temp of I stores up to this index. Okay, only this sum. And then what I'll do is I'll add, let's say I want the new prefix sum up till let's say this ith index. So I will add this prefix sum plus this temporary prefix sum. Okay, so temp of 0 equal to 0, and yeah, I increment the count also. If a of I equal to -1, then I'll do count plus plus, and for j equal to 0, j less than equal to k, j plus plus, temp of j plus 1 equal to temp of j plus dp of plus f of I dash j dash, right? Like we want this to be sum of f of I dash j dash, and f of I dash j dash is what? F of the function is basically dp of ij into k to the power p of I. So up to the ith index, how many zeros have come? So and how many -1 have come? So k to the power minus that value. So basically the inverse of count, k to the power minus count. this is written dp of ij into k to the power minus count, and I'm taking the prefix of this thing. I'm taking the prefix of this thing, so that's why I've added this thing, right? So temp of j plus 1 equal to temp of j plus this, and then I'll just um, add this temp of j to the prefix sum of j. So now in PR array, I have the prefixes up to this row. Like now this row is also included. So yeah, that's how I updated the prefix sum array. So now I have done this DP thing, and I am at the answer variable, like ans equal to 0. And also I have this one more array called post count. Post count means that after the ith index, how many zeros, how many minus ones are there. Okay. So of course last index is 0, and for I equal to n minus 2, I greater than equal to 0, I minus minus, post count of I equals to post count of I plus 1 plus whether a of I plus 1 is minus 1 or not, right? And to calculate the final answer, what I'll do is ans plus equals dp of ij into k to the power post count of I, and print the answer. Okay, so that's my entire solution, and I hope it should be clear. Like since you didn't ask in the logic part, I think the code should be pretty straightforward if you already understand the logic part. All right. So I hope it is clear to all. So yeah, if it is clear, then I will end the stream now. And yeah, thank you all for joining in, and I'll see you guys next time.